Okay, we've been talking about programmatic flow, controlling the flow of your program, the flow of execution, and one of the things we haven't mentioned yet is exception handling. So exception handling occurs when there is an exception thrown in your program, which is commonly caused by some sort of error, and then when the exception is thrown, normally if it's not caught, the application will just exit, and you'll see in the terminal, or if you're in the browser, in the console, you'll see an error message, and you'll see a stack trace that shows you what file the error occurred in and what line number. So let's do an example of an error, and we'll see what we mean there. So let's say we have a variable that's just an object, and we've got some things on here. First and last name. Alright, we have this object, and this is fine, but let's say we try to access a method that's not on there, like say hello. Okay, so we've defined this object. This is an object literal, and we've defined properties first, and that's a person's first name, and last, that's a person's last name, but we never define a property say hello. Okay, so this the coder here in this case, it's me, but theoretically we could have lots of code here, maybe hundreds of lines of code, and then the person writing this file doesn't realize they didn't add this property, right? So they might try to access this property and run it like a function. Okay, and so if we do that, we see node exception handling, and here we have the stack trace, right? We have the file that the error occurred on, so this is where it's located in my on my file system. The line number, it's at line 14, and if we look in the file, we see sure enough it's at line 14, and then it points to where it's having the issue. Okay, and this is sort of ambiguous. It doesn't always do the best job of trying to figure out what the error is, and that's because it doesn't always know all the possible combinations of mistakes a human can make, right? But it tries to make a guess. Okay, so in this case, it is pretty close, right? It's pointing here. There's an issue. What is the error specifically? Well, this is a type error, and object.sayHello is not a function. Okay, so this sayHello property is not a function. Well, if it's not a function, what is it? Okay, let's use our type of console.log, and we're going to see the type of thing that we have here, object.sayHello. So now instead of executing it as a function, we're just accessing the property sayHello on the object, which is not defined. We did not add a property here to this object. So we're using the type of function, or keyword rather, to try to see what type of data is here, because it says it's not a function, but it sort of says that it is something, right? So let's take a look at this. Okay, so the thing that this is undefined. All right, now I know that might be a little bit confusing, but undefined is a keyword in JavaScript. So if I run node in interactive mode, undefined is a keyword, and I can see if undefined let a, and I can see is a equal to undefined. Yes, because I have not added a value yet. Okay, so undefined means sort of what it says, that the variable is undefined, or the property is undefined. So we didn't define this property on this object. So there is no sayHello, right? And this causes an error, all right, and an exception to be thrown. And we saw that when we tried to execute this object.sayHello. All right, so now instead of having the program just exit and throw that error message up, that's not very user-friendly. If somebody runs your JavaScript program and they see this is meant for the developer, right? It shows you information about the error, where it is, what line number, what column number, etc. And it gives a lot more information that you can look into more in depth, right? But the average user doesn't need to see any of this. Okay, so this is a bad user experience. We want to hide this from them because this is going to overwhelm them. It overwhelms most beginner coders too. They tend to see this and just sort of skip over it and not look at it. It is important that you look at this as a developer, right? That's the file name, the line of code, and then it shows you sort of where the error is and the type and the error itself. Okay, so it's important for us to look at it, but we want to hide it from the user. So in this way we can use try. So we're going to try to do something that might cause an error. In this case, this isn't a great example because we know this is going to cause an error, and it's hard to manufacture a situation in which something might cause an error but you don't know. Okay, so and as I said, try catches are increasingly rare in JavaScript, usually in favor of error callbacks instead, but it's still important we know about this mechanism. And it's pretty much the same mechanism in most programming languages. There's some sort of exception handling where there's a try catch, and then you can also throw errors, right? So or exceptions depending on the language, right? So we're going to try to do this one thing, and if it works, that's fine. If it doesn't, if we get an error, we're going to catch that error, and we're going to call that error E. And here, we're going to execute some code if there was an error. Okay, so in this case, we're not sharing all of this information with the user. All right, so we can run this, and it just says there was an error, right? And maybe we would be more specific, but we would put this in user language, right? This is in developer language. This is in computer science language. This is not what the user of your program should see, right? This is user language. There was some error in the program and we're exiting. That's all they need to know. Okay, they don't need to know the details because they don't see the code. They just run the program. All right, so let's take a look at this E. What is that? All right, so I have some variable E, and it's holding the error that was thrown. So the error is just an object. And so we can look and see what's on this object using console.dir. If you've never used console.dir, it basically looks at the directory listing of an object, right? So we can pass in obj, and it lists out the items. That's our object, right? We need the error, right? Okay. So the error itself has a .message property. Let's see, .message. Okay, so that's this part, right? So e.message. Now it didn't show us that. Let's see if we can do console.log. So errors are specifically designed to be printed, and so when you convert them into a string, it just prints out that this message here, right? And it also prints out the stack trace and all this other stuff. But it's actually technically an object, and we see that it's technically an object because I can access the .message property. If it was just a string, like it looks like it is when we print it, right? So here we can just print it, E, right? And it looks like it's just a string. Whereas if we were to print an object, like this object, right, we normally would see it sort of like this. Okay, but that's sort of just a trick of JavaScript. It is actually an object, and it does have properties. So the main property that you should be concerned with is .message. Okay, and as always, you can look up information about JavaScript errors, right? So new error. Here we go. Error reference. reference. So MDN, Mozilla Developer Networks, is a good reference for most things web related. Alright, so these are all the different types of errors you can encounter. Syntax error, reference error, general purpose errors, and so you can look through here, type errors, which is the one we got here. There's several of them, right? And if we look at the error object, the error constructor. Okay, so we see we can create a new one of these errors and we can post the message. So here the message is object.sayHello is not a function. So that was the message that was passed in when this error was created. Alright, so this gets into the concept of objects and the new keyword. Okay, so we haven't talked too much about creating objects from constructors. We've only created object literals like this. Okay, but there is a way that you can create objects from a function. Okay, and so to do that, you define a function, and you usually capitalize that function. So this is the error function, and you can pass in information, and it will create an object using that information in some particular way, right? So new error, right? And so this is essentially what's happening behind the scenes. A certain component of the Node.js engine is creating one of these errors and then throwing it. All right, what do I mean by throwing an error? Well, if I go down here, console.log, we're going to look at throwing. And this was just try catch. Console.log, try catch. Okay, console. So I can throw my own error. And I can create a new error. This is my own special error. Alright, so the throw keyword is throwing one of these errors, and I'm creating one of those errors. Now, when I say creating an error, it's not an error in the code or the logic. This is an error object. Okay, and it can be useful sometimes to throw an error and specify what the issue is, and then you can handle it later. Alright, so let's look at this example. Throw new error. I run this code, and we see that an error was thrown. Here's the message. This is my own special error, and it gives me a stack trace as well. It shows me what line of code the error exists on, right? And it's right here in line 26 where I threw this error. Now if I did this inside of a try block, then I could catch the error. And I can just say caught. Okay, so I threw my own error and then I caught it. Now sometimes any number of errors could occur. Okay, so let's say we have if true, so this is always going to be true, but we're going to change it later. Then we're going to throw this error. We might as well make it a variable, so let custom, we'll say throw custom error. We're going to say that's true. Okay, so if this variable throw custom error is true, right, we're going to throw our custom error. And let's just say custom. And this is our message. Remember, e.message. All right. So we catch this, and I can say if e.message is custom, right, then I have caught my own custom error, but I could have another error in here, right? Else console.log, hang on, caught custom, and then here we have console.log caught another error. All right, so throw custom error is true. We're going to throw this error. Right, and we caught the custom error. But we could have something happen where maybe this is false. Okay, so we're not going to have this error occur. But down here we call obj.foo or something like that, and we try to call this function. And we already know that foo is not a property on obj. Obj is just Bob Smith, first and last name. Okay, so this is going to create an error too. There's two potential cases for this, for there to be an error in this code, and we don't know which one it is, right? So depending on what the value of this variable is, if that's true, we're going to throw this error, and then we catch here, and that error becomes the parameter stored in the parameter e. So e.message. If that's custom, then we know we caught our custom error. If it's not, then we caught a different type of error, right? So if it's not, caught another error. Right, so we can run this, and this time we caught another error because we didn't throw this one because this was false. If we make this true, we caught the custom error. Okay, so the point here is that retrieving this error can be helpful, and you can discriminate between the what that error means using .message, right? And you can even theoretically try to put different messages, and you can define your own custom errors. There are plenty of errors that already exist, but just using a generic error is generally speaking fine. Now there's one thing I want to tell you here. Technically you can throw anything. So I can just throw a string that says my error. Okay. And it says caught another error. All right, that's because this is a bad practice. JavaScript is nice and allows it to work, right? But this might be actually throwing an error. Let's look at what that error is. Console.log and we'll print out the error. Right, so I just printed out E, right? So it is throwing just that string. So there is no E message. If I tried to say E.message, which is the default sort of structure of these errors, this would probably cause an error. I'm pretty sure it will. Let's double check that. Caught another error. Oh, it doesn't throw an error, but it says undefined because the message of the error is undefined. That would be like saying foo.message. The string does not have a property on it called message, so this is undefined. Right? So JavaScript is forgiving, except that forgiving nature leads to other errors that can happen. Right? So this is, in most programming languages, you would not think that the program would work here. But JavaScript is extremely forgiving. It lets you throw all sorts of different things. It's loosely typed, right? So it doesn't really care too much about how you structure your data, right? But that can run into problems if you're not, that can cause problems for you if you're not consistent, right? So here, always throw, when you're throwing something, always throw a new error and then put your message inside. Okay, so this is how we construct a new object. So this is an error object, and we can have any number of these, new error, and we're going to go into objects a little bit more. But just remember, always throw an error right? Don't throw a string, even though JavaScript allows it. As I mentioned before in previous videos, JavaScript was a very quickly developed language, and it was evolved very, very quickly. And so because of that, and because of the need for backwards compatibility, there's a huge subset of JavaScript that is considered to be the bad parts, things you should avoid. So this is some of that stuff here, right? So don't throw naked strings, just raw strings, right? We want to wrap that in an error object, all right? So make sure we're using the good parts of JavaScript. All right, and there's one final thing we want to look at here. We have the try catch block, right? And we can throw our own errors, right? And then there's also finally. So the finally block is going to run regardless of the success of the try block. Because it could be that the try block succeeds. The whole point of the try block is we don't know if this is going to cause an error. Sometimes it might. If it does cause an error, then we want to handle that error gracefully. But if it doesn't cause an error, then that's fine, and it should just run as normal, and then we'll skip over the catch block. Now the finally block will run always. Console.log finally always runs. Okay, so we caught the error, and so even though we were in the catch block, the finally block ran, right? And it's important to note too here, console.log, this is the beginning of the try block. If I can type that right, try block start, and semicolon. Now notice we did start executing the try block. So all of this stuff is executed until there's an error encountered, and then it stops executing the try block and moves into the catch block. So just because one thing breaks in the try block, everything before that error is still going to get executed. So we see try block start. We see that it did execute, right? But then we moved on to the catch block, caught another error because one of these two threw the error, right? So throw custom error is true, so that means this was the error that was thrown. And then we see e.message is, we would want to put custom here, right? So this, before it said my error, which would be caught another error because it didn't equal custom, but now we're setting it back equal to custom. And now we see it caught our custom error, and then the finally always runs. Well, what if we comment out this code, and so there's no possible way for this to throw an error, right? So we've got this try block, so there's no way this is going to cause an error, which means we're not going to execute the catch block. Okay, try block start, and then the finally runs. Okay, we see that the finally always runs either way. Now an argument could be made that you could just do this, and that's sort of the same as a finally, and there are a few cases where that's not entirely correct. So finally is usually reserved for cleanup code. So if you're doing something advanced, and regardless of what happens with your try or your catch, at the end of it you need to clean some code up. Generally this comes up to prevent code duplication. So you might have, cleanup here in the catch, some cleanup function, and then if everything goes well, you have to clean up as well. So you've got this duplication, so you can pull that out and put that in the finally block. Okay, but again, as I mentioned before, try, catch, and especially finally do not come up a whole lot in JavaScript, but it is important that you know what they mean when you do see them, because they do show up. All right, so that's the try, catch, and finally. So that should be enough for this video.